Welcome to G Fun Facts Online, where we dig into the science that shapes our world. Today, we're talking about a silent, invisible network that keeps a constant watch over our entire planet. It's a high-stakes blend of geology and global security, designed to answer one critical question: was that an earthquake or a secret nuclear bomb? In a world where the ground can shake from both natural and man-made forces, a sophisticated system works around the clock to tell the difference. At the heart of this global surveillance is the International Monitoring System, or IMS. Established under the Comprehensive Nuclear Test Ban Treaty, this network will eventually consist of 337 monitoring facilities, spread across 89 countries. It's already about 90% complete and has a stellar track record, having successfully detected all 6 of North Korea's declared nuclear tests. The IMS isn't just one thing, it's a team of 4 different technologies working together. First, you have seismic monitoring, with 170 stations that measure shock waves traveling through the Earth. Then, there's hydroacoustic monitoring, which uses 11 stations with underwater microphones to listen for sound waves in the oceans. 60 infrasound stations listen for ultra-low-frequency sound waves in the atmosphere. Sound so low we can't hear them, but a massive explosion can't hide them. Finally, 80 radionuclide stations act like planetary noses, sniffing the air for the radioactive particles that are the definitive, smoking gun evidence of a nuclear blast. All this data streams in real time to a central hub in Vienna, where it's analyzed and shared. So how do scientists actually tell the difference between a natural earthquake and a clandestine explosion? It all comes down to their seismic signatures. Think of it this way: an explosion is like a sudden, violent push outward in all directions. This creates powerful compressional waves, or P waves. An earthquake, on the other hand, is caused by rocks slipping past each other along a fault line. This generates much stronger shear waves, or S waves, which shake the ground from side to side. By comparing the strength of the P waves to the S waves, scientists can get a pretty clear idea of what caused the tremor. Another clue is depth. Nuclear tests are almost always conducted relatively close to the surface, while most earthquakes originate much deeper within the Earth's crust. These fundamental differences create distinct patterns on a seismogram that trained eyes, and now artificial intelligence, can spot. And the technology is only getting better. Machine learning algorithms are now being trained to sift through immense amounts of seismic data, spotting faint signals that a human might miss. Researchers are even turning thousands of miles of existing fiber optic cables into dense networks of seismic sensors, a technology called distributed acoustic sensing. This gives them an unprecedentedly detailed view of the ground beneath our feet. The nuclear tests conducted by North Korea provided a perfect real-world stress test for the entire system. When the first test happened in 2006, the IMS was only 60% complete, but it still picked up the signal loud and clear on over 20 seismic stations. By the third test in 2013, 94 seismic stations and 2 infrasound stations registered the event. Later, radionuclide stations in Japan and Russia detected radioactive xenon gas, confirming its nuclear nature. This shows the power of the multi-technology approach. Seismic data says something happened here, and radionuclide data can confirm exactly what it was. Of course, challenges remain. Detecting very low-yield explosions is tricky, as their signals can get lost in the Earth's natural background noise. And a new concern has emerged. Could a large, natural earthquake be used to mask the signal of a nearby nuclear test? Scientists are actively working on these problems, running controlled chemical explosions to refine their models, and developing smarter algorithms to untangle complex signals. The seismic detection of underground explosions is a remarkable achievement. It's a field where we translate the subtle language of the Earth's vibrations into a powerful tool for global peace and security. As technology advances, our ability to listen to the planet's faintest whispers will only get stronger, ensuring that no illicit explosion goes unheard. Thanks for tuning in to G Fun Facts Online.